For number 4, we're looking at this. We're always looking for a GCF first. I do not see one. We have a trinomial with a coefficient here in front of the x squared. So it looks like we're going to have to use modified grouping. I'm going to take this -3 and this 12. I'm going to multiply those together to get -36. Then I have to find factors of -36 that add to -5. Let's see, 9 and 4. I'm thinking, so -9 and +4. If we chose 9 and -4, we'd get +5x here. We can't use that. We know we're close if we get the right answer but the wrong sign. But we know we have to use a -9 and a +4, and that'll get us -5 here. So we'll rewrite this 12x squared minus 9x plus 4x minus 3. Group here, group here, group here, group here. I always want to include this sign in this back parentheses. I'll look for GCFs for each group here. So for here it looks like I have a 3x, and I'm left with a 4x minus 3. And here, since I don't have anything common and this sign is positive, I'm just going to pull out a +1. Everything stays exactly the same in there. Now I GCF out these 4x minus 3's, and I'm left with 3x minus 1 there. This is our factored form. Let's look at number 5. 2x squared plus 5x minus 12. Let's look for a GCF here. As always, I don't see one. So again, we have to use modified grouping because there's a coefficient here in front of the x squared. Again, we can use modified grouping for any trinomial. It's just a little bit easier, I think, to use the Katz method when there's no coefficient here. But do what you want. Grouping will work. It'll just mean extra steps, which means more chances to make mistakes. -12 times +2 is -24. I need factors of -24 that add to +5. What do we got? 12, -2, that won't work. 8, -3, that adds up to 5. That multiplies to -24. Let's use that. So I'm going to write this 2x squared plus 8x minus 3x minus 12. I'm going to group here and here. Again, I want to include this and this sign in the back parentheses. Let's look for a GCF here. I'm going to pull out a 2x, x plus 4. Here I'm going to pull out a negative because this sign's a negative. And then I'm going to pull out a 3 because that's the GCF. Then it's going to be x plus 4 here because I'm going to change that sign. I always change signs when I factor out a negative. X plus 4 and x plus 4 here. I'm going to GCF those out. So I get x plus 4, 2x minus 3. That's our final factored form. Let's look at number 6. This is where it gets interesting. We have a times the quantity x minus y minus the quantity of y minus x. How the heck do we do that? It doesn't look like a trinomial. It doesn't look like a, well, I guess it's a binomial, but we can't GCF an x minus y and a y minus x there. But these are considered opposites. These will add up to the same number but just different signs if you plugged in numbers for them. So what we can do is factor out a negative of this thing and just switch it to x minus y. So what we'll do is when we factor out a negative, we're going to switch the order of these and we're going to change the sign of the closest sign you see to the left of it. In this case, it's going to be this negative right there. So we can rewrite this as a x minus y plus, because we're changing the sign because we factored out a negative here, and now this becomes x minus y. Now this is a binomial, very similar to if we had, I'm going to write it up here because it's just an example. If we had a c plus c, I can factor out a c and it becomes a plus 1. Think of these c's as these x minus y's. So I'm going to factor out an x minus y. Then I'm going to be left with a plus 1. There's an imaginary 1 there. Anytime you factor something out and there's nothing left, you got to put a 1. This is our final answer for number 6. Let's look at number 7. We have 75 t to the 4th plus 60 t to the 3rd plus 12 t squared. This is the first one I see where we have a GCF. I've been looking for it all along. This is the time I finally find it. I'm excited to pull some numbers out because things are going to be a little bit easier. It looks like the best thing I can pull out is a 3. I'm going to pull out a 3, and I can also pull out a t squared. That's the smallest power of t that I see that's common to everything. So I'm going to get 25t squared plus 20t plus 4. This is done for the purposes of this problem until the very end. This is just going to keep working down until we have our final answer. Let's look at these now. What kind of number is this? It's a trinomial. It has a coefficient here, so we're going to use modified grouping. This in truth is a perfect square trinomial, because if we take the square root of that, we get 2. If we take the square root of that, we get 5. If we multiply that by 2, we get 20. So you could do it that way, but if you've forgotten that way, you can easily factor this with modified grouping. 4 times positive 25 is positive 100. What factors of positive 100 add up to positive 20? Well, that's positive 10 and positive 10. So I'm going to rewrite this: 25t squared plus 10t plus 10t plus 4. I'm going to group. Let's GCF something out here. I'm going to pull out a 5t. I'm left with 5t plus 2. I'm going to factor out a 2 here, a positive 2 I should say. I'm going to be left with 5t plus 2. I'm going to GCF this 5t plus 2 out, or these, I'm going to pull one out, 5t plus 2, and then I have 5t plus 2 there, and I'm going to bring this 3t squared down. So we end up with this as our almost final factored form, but since these are exactly the same, again, this is a perfect square trinomial, so it's going to be 5t plus 2 squared here, and then we bring down this 3t squared. This is our final factored form for number 7.